So DMA, direct memory access. So DMA, it is directly we can access the memory without intervention of CPU. That means without interrupt of CPU. So you see the diagram. So there is a microprocessor. Microprocessor we consider as a CPU and input output ports. So through the input output ports, that means peripheral devices directly access the memory without interrupt of CPU. So totally the data transfer, the data controlled, handled to DMA controller. So that DMA controller through DMA data bus or memory bus, this will be transfer between input and output devices and memory unit. The data will be transferred. So see the peripherals. So what are the things? Secondary memory, peripherals. So many things. Without interruption of CPU, using DMA controller, they can change. They can access the memory. Here, this is the uh, chip of DMA controller. How in real 8257. That's the number. So the device transfer the data directly to or from memory without any interference of CPU. So this is called as DMA controller. So DMA pin configuration. So totally it has 40 pins. So the pin 20 is a ground, and pin 13 reset, 12 clock, and control select pin is 11. HLDA 7, that is important here. HLDA and data bus pins T0, T1, T2, it will start at 30. Then 21, 22, 23, like that is going. Okay. Then next, how DMA operations are performed. So if peripheral devices want to send the data between the devices, first of all, the DMA request DRQ, that's sent it to DMA controller. That any devices want the data, first they will ask the request through DRQ, that is DMA request. Then DMA controller sends hold request HRQ. So hold, can you request, you given the request, I just hold it, then I just ask to CPU. So wait for CPU, just like that the whole request send it to, so which devices already asked DRQ. The CPU wait for the CPU, then asserts HLDA. The CPU, the microprocessor, data bus, address bus, control bus, the CPU leaves the control over the buses and acknowledge hold request to through HLDA signal. Now CPU is hold state. Then DMA controller has managed the operation and over the bus between CPU and memory and input output devices. So this is a basic architecture. So they have the channel 0, channel 1, channel 2, channel 3. So there are 4 channel you can access. So peripheral devices can connect with the channels. So first they will ask DRQ request. So 4 channel they will ask to DRQ. Then there is a priority resolver is there. So priority resolvers is give the priority which is may 4 variable ask at a time, then which we have to give priority. The priority is most to 0. Okay, priority given to 0, then 1, 2, 3 like that. Then after getting DRQ request from peripheral devices, then that will be give HRQ, HRQ to CBU. That DMA controller send the HRQ to CBU. After CBU got HRQ, then that will leave all the control, even data bus, control bus, address bus, everything. Just leave it. Then it will give the then the CBU went to hold state. Then it send the signal to HLDA to DMA controller. Then that will give final thing to DAC 0, DAC 1, DAC 2 like that. That will send it to peripheral devices. So then they will ask directly without the interference of CPU. They directly access the memory. So number of bits, common representation theme here. So 1 is a bit, digit flag, 4 bit, 0 1 0 1 like that. So 4 bit we can call as a nibble, 8 byte, 16 double byte. So these are the basic information for binary sequence. So see, same. So this is another information. So what are the features of 8257? So there is a 4 channels available input output devices. So each channel has 16-bit address and 14-bit counter. And each channel can transfer the data up to 64 kbps. And each channel programmed independently. And each channel perform read transfer, write transfer, and verify transfer operation. It generate mark signal to the peripheral devices that 128 byte have been transferred. It required a single phase flag. The frequency range from 250 Hz to 3 MHz. It operates two modes, one is master mode and slave mode. So now they are explaining signals. Just now we saw about signals. The DRQ is a request from peripheral devices. D0 D7 is a bidirectional data lines. Data bus, the DMA controller to send the data through this data bus. So IOR, active low bidirectional state input lines. Then clock. Clock frequency signal which is required for internal operation 8257 and reset the DMA controller. It disabling the DMA channels. There are 4 channels are available that will be disabled by this reset, and the A0 A3 the least significant address lines. So they select one of the register to read and write the master mode, and chip select line is a slave mode. It enable read and write operation to or from 8257. So in the master mode, disable read write operation to 8257. That means chip select. In the slave mode, it enable read write operation to or from 8257. In master mode, it disable the read write operation to 8257. So similarly, highest nibble of lower byte address generated in GM master A4 to A7 and ready the input signal is ready inserted to wait states. HLDA acknowledgement signal from DMA controller that bus granted to the requesting peripheral by the CPU. Then MEMR low memory read signal which is used to read the data from addressed memory location during DMA read cycles, and MEMW it's write the data to address memory location during DMA write operation, and AEN is used to disable the address bus and data bus, and TC terminal count which indicates present DMA cycles present peripheral devices, and mark activated after 128 cycles that integral multiple of from it will be start from the beginning. It will indicate current DMA cycle have 128 cycles. So VCC is a power supply. So these are as DMA controller. Thank you.